Good afternoon, everyone. Thanks for joining us today. My name is Brian Murphy. I'm the marketing specialist here at Dices. I'm pleased to be joined by Emre Sinir, a specialist in retail analytics and a member of the Dices Expert Network. I'm going to go ahead and let Emre take it from here. If you have any questions, be sure to write them into the questions box, and we will address them at the end. Thank you. Emre?
Hello, everybody. Welcome to our webinar. Today I'm going to be covering retail analytics and mainly with a heavy focus on the forecasting side. We'll just cover the agenda first. I'll introduce myself in a moment. The next topic we will get into is, forecasting in retail and in the predictive analytics space. What are the different processes it interacts with, and how can we make best use of forecasting in general. Then I'm going to start discussing some of the challenges in forecasting and what are some of the key features that any forecasting application or system should have. But I'm going to discuss it using Oracle Retail's demand forecasting system as an example. I'm going to highlight some of the features and functionality that RDF Oracle system provides to address these features. But to address these challenges, but I'm also going to talk about some alternatives to that as well. Then at the end of the webinar, we are going to get into some of the implementation and post-implementation considerations. I know some of you out there are considering to implement a new system, or maybe you're considering an upgrade on your existing system. So what are some of the key call-outs that you should think about? I'm going to try to get into that area as well. So I have been in consulting world for over a decade. I think I'm in year 13 now, actually. So I have started at Retech, which is now Oracle Retail, and I have also worked with a company called Predictive, and recently I've been doing independent work. I have, in my career, I worked with retailers of various sizes and various size projects. Main focus has been forecasting, but also planning, inventory optimization, and price optimization. So I would like to kind of share my experiences with you to the most I can in this hour, and would be happy to answer any questions you might have. So with that introduction, before the webinar, we asked the attendees, when do you plan on implementing a demand forecasting solution? And 67%, two-thirds, have said we already have a current system in place. That means that there is no consideration for a new system in near future. But there's a 9% that is looking to implement something really soon, within the next 6 months, and 24% of the attendees are looking to implement a new solution within 18 months plus. I guess within the 18 months, that's what we meant there. So that is how the graph worked out. Now, let's get into forecasting in retail, and because it's kind of forecasting is the key of predictive analytics space. And forecasting is predicting future events through analysis of data from past and present. So that's how the basic definition we can use for the purpose of this webinar. So if you don't have past or present data, you cannot really talk about a forecast. What you may be thinking about is maybe a guess or a prediction, but really forecasting involves some type of analysis and some type of algorithms that we should apply on an existing data set. And that's how we drive our predictions into the future. The main interactions in retail space that forecasting interacts with is definitely number one. I would put replenishment. I'm sure you all are familiar, but replenishment is the act of reordering items that you sell in your stores, and if you there are various replenishment algorithms out there. You can just replenish based on your inventory levels. You can have min-max algorithms or constant algorithms, or you can even have some other more sophisticated algorithms that are purely based on your inventory levels. However, also one way of doing the replenishment is through forecasting. If you have a demand forecast out there that you're feeding your system with some understanding of how much variation is built in, that's typically is going to yield the most accurate results, especially for fast-moving items in your stores, which are very seasonal, could be seasonal, and could have up and downs in your demand in its demand curve. Planning is also another area, of course. If you're doing merchandise financial planning, maybe you need to do some trend analysis, or if you're opening new stores and or you're closing some stores. So those are all trends, and seasonality can be a factor in how you plan for next year. Inventory and price optimization, these processes will require having some notion of what the demand is going to be, or your price elasticity, how your products respond to changes in price. So those are all good outputs that can come from forecasting. And of course, price and promotion management, understanding how your promotion is doing, what is a typical response to your promotions. Those are key elements that can be kind of derived from your forecasting system, and definitely would be a valuable input to your other applications. So this is kind of a very high-level, 30,000 feet view of where where forecasting can fit in your organization, and definitely when you get down to the details of the organization and the applications and the availability of data, the pictures change. But this is kind of a very high-level overview. So when we talk about replenishment in particular, just to illustrate, the effect of a proactive forecasting-driven replenishment versus a reactive inventory levels-driven replenishment system, or just looking at recent history, if you will. In this, what this graph tries to illustrate is this blue area, or this line right here represents the demand. The black line. And as the demand is ramping up and you're going into a season, if your replenishment is kind of in a reactive mode, what you will always end up with is trying to keep up with that demand. And because depending on your lead times, it's likely that you will be suffering this red area where you are losing some sales opportunities because you cannot keep up with the demand. Because last week's demand or the weeks before's demand is not going to be representative of what you sell next week. And anytime that happens, you will suffer some lost sales. And on the opposite of this curve, when your sales are dropping, because you're kind of looking into the recent sales or recent inventory numbers, you may suffer a different phenomenon and may get stuck with some excess inventory, and you may have excess capital tied up where you could be using that for other areas in your organization where you can get a better return on investment. So either shape is not ideal, right? So the ideal shape is you know what your demand is going in, and you order ahead of time for that, and you kind of carry just a little bit excess inventory so that you're ready for any variations, and but you don't carry too much excess inventory, and you definitely avoid lost sales. So that's the ideal world that forecasting may enable you to get to. So when we get into some of the challenges in forecasting, the number one challenge for any forecasting solution out there is scalability. Because in retail, typically, retailers have tens of thousands of SKUs, and if not hundreds of thousands of SKUs, and hundreds of stores, if not thousands of stores. And you typically need at least a weekly forecast, if not a daily forecast. So when you multiply, let's say a 100-store retailer with, 10,000 SKUs in their assortment, that makes 1 million SKU store combinations. And if you multiply that with, let's say, a 26-week forecast, that's already 26 million numbers that you should be looking at on a weekly basis. So scalability is definitely important. I think with the rise of the cloud-based applications, hardware constraints are going away. There are a couple of vendors out there that are, doing quite interesting stuff in the forecasting area. So definitely worth taking a look. But scalability, definitely for any forecasting application, it needs to be retail-centric, and scalability is an area that you should think about. So once I have this huge number of forecasts, the other thing that the forecasting application should enable me to do is to manage those forecasts in an effective way. And if we were to look at 26 million forecasts on a weekly basis, I would need to hire I don't know how many forecasters just looking at those numbers, and that's of course not effective and not efficient. So what typically the forecasting applications do is they define a bunch of rules and criteria and exception rules that will allow the users to focus on what's really important and what's really outside of acceptable norms. And the efficiency of these processes may vary, and the efficiency of the rules may vary, but definitely a key area, and it's usually an area where customers learn, clients learn over time, like how to make the most use of going forward. Sparsity is an area where, an issue for retailers as well. Sparsity, what I mean by that is your data has lots of zeros. That's a very simple definition of a sparse data set. So it's very typical in retail that some of your items will not sell every week. There could be even items where it doesn't sell for 3-4 weeks in a row, and then when they sell, you may sell 1 unit or 2 units, or somebody may come into your store and get 3 or 4 of that item. And it's when the difficulty with these type of data sets is when you look at them individually, it's almost impossible to make sense of where your seasonality lies. Is there a trend going up, or is it trending down? What's my average? So those kind of questions are not trivial to answer when you just look at your data set. And there are ways of addressing that, so I'm going to cover in a little bit. The wide variety of algorithms, that's another challenge because, typically forecasting applications come with these fancy names, winters and crustons and intermittent and exponential smoothing or stepwise regression. So there are all these different techniques out there that are available to use, and typically the retailers are not scientists, and they don't necessarily know which one will work best for every situation. And the tool needs to provide at least some functionality to make that selection easier. Definitely a consideration for you when you're looking at forecasting solutions out there. New products and new locations. Calling this forecasting is maybe a little bit stretched, but there are techniques out there that will allow you to manage new products and new locations, and they almost certainly rely on some type of expert knowledge or expert opinion about similarities to existing stores or existing locations that you have. But once you have that established, that relationship or that similarity, there are techniques available that can at least make use of that information to manage the forecasting new products and new locations. And finally, ease of manipulation. And what I mean by that is that really manipulating data should be easy in a forecasting system, because it's very data intensive. It's a lot of numbers and a lot of number crunching and a lot of potentially adjustment of forecasts. And you need to be able to make those adjustments relatively easily at various levels of the hierarchy, and that should not take too much of the user's time in an ideal world. So those are all kind of key functions, features, challenges, whatever you want to call them, that should be present in forecasting applications. So I'm just going to go through some slides to illustrate some of these challenges. So this is, and I'm using Oracle Retail Demand Forecasting Solution as a poster child for this process. Here is this is on the automated exception reporting. So in RDF, in Oracle system, there's a process where you define these rules that will highlight the exceptions for you. So in this example, 200 stores, 5,000 items in 13 weeks, that's 13 million forecast values. So instead of going through 13 million forecast values, as you can see, there are different priorities and different rules that have been defined. Some of them do not have any counts, any hits, and some of them do. So by selecting these rules and the number of SKU store combinations that are that have that exception, you can make most effective use of your time, and you can really focus on what's important and what will give you the most return on your time investment in terms of reviewing the forecast. Different, like I said, different applications have different flavors of this. However, one way or another, exception reporting is critical and it should exist. So this is an example. I have a couple slides on overcoming data sparsity. As I explained, data sparsity is something. The analogy I'm going to use here is like if you're too close to a picture and you look it up, you're zoomed in all the way. It's really hard to understand what the pattern looks like, what the picture is telling us. But as you zoom out, the patterns start to emerge, and if you're at the right zoom level, if you will, you can see the big picture and you can understand a lot more about your data. So the kind of corresponding concept in forecasting for this is what we call aggregation. So instead of zooming out, you're summing data across parts of your hierarchy where you're trying to make sense of the big picture. And in RDF, they call this source level. Source level is the level that you aggregate to. And that's really where you start your analysis of the forecast. So when you look at your SKU store level, for example, the data will be very sparse, lots of zeros and ones. But when you go to, let's say, SKU chain week, when you sum it across your stores, it's going to look like, okay, this SKU has a high peak, during Christmas, or it sells more during winter, it sells less during summer. So whatever the case might be, and there's a trend going up, or those patterns will be much more visible. So in RDF, like I said, the level that you aggregate to is called source level. There are different variations across different applications, but again, I'm using RDF as an example. However, once you have that big level, big picture figured out, you still need to get your forecast down to the lower level, because that's where you can use it for replenishment. Maybe that's where you need it for your promotional management tool. Typically, there's a level where you need to get your output at, and that's typically different than the level you get the big picture. And so what you need to do is you need to get that high-level forecast down to that lower level that you need the output at. And the process for that is, spread. You need to pretty much spread your high-level forecast down to the lower level. And there are techniques that allows you to do that in an effective way. Some are just use ratios from historical data. A contribution % of that store, or a contribution % of that color or size can help you get to that lower level number. Or there are also some techniques where we do actually analyze those zeros and ones at that low level and come up with an average, and that average drives or that forecast drives how we would spread down. This is an illustration of that process. Think of these A, B, C, D, E as different stores potentially, and these stores are aggregated to a higher level. Let's say this is my skew chain level, and at the skew chain level the numbers look, I have less zeros because I sum it across the stores, and now from these numbers I derive another set of numbers, and this is based on the different forecast algorithms that are available to me. And once I have this feature looking numbers, I spread them back down to my stores. So that's kind of the overall process. Like I told you, also the other challenge that's available is, I have a bunch of algorithms to pick from, and I don't know which one to use, when to use it. What RDF does to address this scenario is they have developed a kind of a super algorithm called automatic ES, and ES, by the way, stands for exponential smoothing for anybody who's interested. RDF has a family of exponential smoothing based algorithms that's available to it, and what AutoES does is it actually kind of runs each one. It evaluates its accuracy or fit, and based on how the different fits compare, it will do a selection for you. It will say, for example, for this time series, I think additive seasonal is my best fit, and therefore it will automatically use kind of eliminating the need to pick one of these and automatically picking one for you. And the exponential smoothing family kind of evaluates three values: level, trend, and seasonality. Those are the three components. Once you have those three components, you get a number for what your forecast is. There are also two other families that's available to forecast as an algorithm that's not part of AutoES, and that's Bayesian and causal. So I'm going to talk about each one. So causal forecasting, this is really important, especially for retailers in the more hardline space and grocery space, because there are lots of staple items that you carry all the time and you promote similarly all the time. So this is when the causal forecasting is at its best, because because it derives its information from the past. It needs to have some examples of the promotions in the past that were similar for that item or for similar items, so that it can make use of that history and it can predict the future. So what you're looking at here is this purple line is, let's say, the actual sales or actual demand. And this X, what it tells us is that on this point in my history, I had a promotion. Let's say I had a buy one get one promotion. And then what my task is to generate a forecast for this period right here, and to forecast this X where I'm repeating the same promotion, the same buy one get one promotion. So in order to achieve this, what the system will do is it's first going to try to understand what the baseline demand is on the week that I had the promotion. And the way we define baseline demand is, you can think of it, what would I have sold on that day, or on that week, if I didn't have the promotion I had. So if I didn't do a buy one get one, I would have sold this much. So that's kind of the idea. And the reason this is critical is in order to understand the incremental lift, you need to have that point of view on what would have sold if you didn't have that promotion. And there are some algorithms, again, that allows you to do this in a sophisticated way. It typically smooths out the neighboring data points on either side of the promotion, and kind of bases it on that to come up with what the baseline demand is. But once it does, what it will do is it will calculate an effect. So it can say, let's say this point right here is, let's say, 10 units, and your actual sales came out to be 30 units. So that's an incremental effect of times 3 that it captures here. Of course, I'm oversimplifying this. But once it forecasts the baseline into the future, and it does use an exponential smoothing method to forecast it into the future, it will apply the same effect on top of the data point where you have this promotion happening in the future. So let's say it was 15 units on this data point. It's going to adjust the forecast to 45 units because it has an incremental effect of times 3. So this is kind of a very simplified version of what RDF, the Oracle system, does in terms of analyzing causal forecast or coming up with causal forecast. Again, especially this is one area that's very calculation intensive, and historically, even though we had the formulas and algorithms available to us, there's not like there's some brand new science that people are coming up with great algorithms. But what's changing in this area, I think, is the cloud is kind of eliminating the limits on the calculation power. And because that calculation power is now a lot bigger, and you don't have to invest in, $10 million of hardware to get that, it is kind of opening doors for some more advanced algorithms to be deployed in retail. And I think that's a key improvement that is already happening. On the Bayesian forecasting side, Bayesian forecasting is a kind of different from exponential smoothing and different from causal forecasting, because what it assumes is the existence of a plan, a pre-notion of what you're going to sell and what your seasonality looks like. So it uses that as the guiding principle or guiding factor to derive the numbers. So all it will do is it will take your plan, which is the red line here, and it's going to compare it against the actuals as they come in. So in this illustration, as the actuals are coming a little above, slightly above the plan, and what you're seeing as the amended forecast is that it's settled somewhere between the actuals and the plan. It's kind of adjusting it upwards from the original. It's modifying the original plan to take into account that you are selling more than you originally thought you would. And when the situation is reversed, when your actual starts dipping, your forecast will follow, and it's going to adjust your plan again, this time the other way. So when is Bayesian good and used? It may be good for some new SKUs. It could be good for some new stores, definitely items and locations that have not a lot of history. So you start with a seasonal curve and you start with a pre-notion of what you're going to sell. It will also be good if you have an advanced, if you have planners who are putting in the effort and you have a good planning organization. It will also be helpful when you don't have long history on certain products. So these are products that you carry for limited time and you still have a need to forecast because you have a chance to reorder mid-season, for example, or maybe in the first 2 weeks or in the first 5 weeks, whatever the case might be. Bayesian forecasting can be considered as an option. So that's just some overview on the different forecasting methods available to you. Forecasting new products and new locations, that's always have been a challenge with retailers because of the fact that you really have to base it on some type of expert opinion. There are ways you can cluster them. You can do trait analysis and attribute analysis for SKUs and try to get the system to give you some type of guidance. However, it ultimately will come down to some expert, some buyer, some merchant, some planner, some forecaster looking at it and deciding what this new store that you're opening in Tampa is going to be doing. And typically, in my example, you can say this store in Tampa is going to be similar in terms of demographics and the area to my, let's say, Miami store. So what I'm going to do is I'm going to copy my forecast from that Miami store into my Tampa store. And RDF does allow a bunch of variations of this. So you can either copy history to the new store or to the new product. You can copy the forecast from one to the other, or you can copy the history of the existing item or location as a forecast into the new location. And so just to clarify that, for example, if you had a grand opening in Miami last year and you think that grand opening curve is something unique and you want to capture it similarly for the Tampa store, you can capture that grand opening curve from your history and use it as a forecast for the new store. So there are some variations of this, like I said, but the point is the new products and new locations are always a challenge in forecasting, and when you're looking at systems or when you're looking at implementing a new solution or improving your existing system or doing something in-house, you should kind of give it some thought, like what would work best in your organization, and define processes accordingly. And my final point here is, forecasting is very data intensive. It's, it requires a lot of, there are lots of numbers to look at and try to manipulate. So ease of manipulating the data is definitely important. A lot of forecasting applications out there use what we call multidimensional databases instead of the relational databases. And these multidimensional databases allow faster aggregation and spreading. So the architecture of the database makes it easier to manipulate the data. I can kind of, for those of you who are familiar with pivot tables in Excel, that may be, a good, maybe that will help you understand what the multidimensional database would behave like if you're not familiar with it. So RDF is, the Oracle solution is based on RPAS. RPAS stands for Oracle Retail Predictive Application Server. It's based on multidimensional database, but I won't bore you with a lot of those technical details unless there are some questions at the end. Okay, so kind of an overview of the different challenges and what you should be looking out for. And once you've made your choice and you're either building it in-house or you're working with the vendors or you're improving your existing system, there are certain things that you should be aware of so that you make your implementation a success. And I think the number one rule of the implementation success is good design. Good design will set you up for success, or a bad design will set you up for failure. No matter what you may do towards the end, or you put a lot of people in, you put a lot of effort in. If you start with a bad design, that's usually a very costly mistake to fix. It may be you may create some throwaway work, or can create some extremely inefficient, ineffective processes or technical architecture. Therefore, it is important that you put in the effort in the design process. You engage your best business experts and technical experts, and especially during that design period, you shouldn't consider that as a secondary effort, on the side of your employees' full-time responsibilities. It should be something that you really focus on. The number two consideration should be the implementation team. So when you work your implementation partner, whether you build a team in-house or whatever, you have to make sure that you have a diverse team, diverse skill set that addresses the different areas that you would help with. You have to have a good technical team in place. You have to have a good business team in place, and you have to have project management in place, and of course, maybe a steering committee in place. So the selection of the team is important. And sometimes I've seen projects fail because it was a purely IT-driven project and maybe not enough business involvement, or vice versa. And just having a diverse team and good representation from each team makes it much better and much easier. Data availability. Forecasting is predicting future based on past and present data. So if your data is not good, your forecast is not going to be good. I'm sure you're familiar with garbage in, garbage out kind of famous saying. So before you even attempt to take on a forecasting project, I think you either should be sure that you have sufficient data and good quality data, or if you don't, the first thing you should do is to start gathering that, or maybe look for ways on improving your data quality, and implement those processes first, then consider doing the forecasting bit, because just doing the forecasting without data is not going to yield good results. Executive support for the project. I guess this is not special to this forecasting project. That's definitely important for any project that the company engages in. But definitely, if there are executive support on the project, good focus, steering committees or project boards, those tend to help a lot. And especially if there are key decisions that are pending, executive review or approval, making those decisions as speedily as possible will definitely help you expedite the implementation. Realistic expectations. Those are, again, this applies to every project, but don't think that throwing resources to the project just will make it faster. Don't assume that, because sometimes that's not a solution. There are just, things have to take their course, and there are certain steps that need to happen before the others. So, when you're engaging into this project, do take sufficient time up front to really establish what would be realistic to achieve. And maybe if it doesn't fit in your budget or it doesn't fit in your timelines, then the next step would be considering what can be feasible in that timeline or in that budget, and maybe you take some smaller bites at the project and you try to digest it in smaller chunks. But some reality check is definitely helpful. And finally, this is one area that gets ignored or maybe kind of considered secondary: change management and training, especially for those of you who are considering to implement a forecasting solution for the first time, or it's a brand new system, it's a kind of a heart transplant for your business. Change management and training definitely are areas where you should not put as secondary thoughts. They are part of they should be considered as primary as the implementing the solution, because if your user community doesn't know how to use the system, or you don't train them properly, or you don't have the necessary support processes in place once things are live, you haven't defined the roles appropriately, you will not get the benefits you're looking for out of the gate. Of course, things will start fixing themselves over time, but that may be very frustrating for the people who are using it, and may also yield in some financial losses for the organization. So, nothing too dramatic here, but definitely just call outs that I think you all should be aware of, and should make sure that you pay proper attention once you're taking on a project like this. And the considerations don't end during the implementation or pre-implementation. After you're done, you still need to make sure that you have the technical and functional support for your users, and you have the proper maintenance of the system. And in forecasting, accuracy monitoring and reporting is one way of achieving that. When I started, let's say I had 20% error. Is it really 20% still? Is it going to 25? Is it 18 now? Am I doing better? Am I doing worse? If I'm doing worse, why am I doing worse? Understanding those and monitoring those, it's definitely something I highly recommend, because it's, the implementation teams will probably disappear after the implementation is done. So, keeping a check on the health of the system is crucial for ongoing. And optimization of parameters, that's another area that a lot of companies, that's relatively something easy to do and can yield to significant improvements in your forecast accuracy, and can yield to maybe improvement in sales and improvement in inventory levels. However, a lot of companies don't necessarily know how to do it, or don't engage with the right experts who are capable of doing it. It's something like it's really a good return. Typically, these projects have good ROIs, because you're just squeezing more from your existing system instead of taking on something from scratch. Just no matter what your system is, what are the different options out there for my parameters? How, if I go to a little more granularity in terms of maintaining them, managing them, can I get some more juice from my existing system? And typically, most of the cases, the answer is yes, and something worth considering for you, even in a post-implementation world. And user performance monitoring, if you're tasking your users to review the forecast, approve them, adjust them, you should also be providing the users some feedback on if their adjustments are in the right direction or in the wrong direction. There are capabilities in RDF, for example, where you can look at the accuracy of what the system said and what the user actually adjusted. And it's easy, after a couple of weeks when you got the actual results, to compare the two and to provide feedback in user actions. And it shouldn't be necessarily, it should be a kind of a positive criticism, and hopefully, you'll identify areas where they're not making the right adjustments and, improve them for the better. Two final points: super users, champions. Having somebody who's really into forecasting and who really understands deep in the algorithms and the capabilities in your organization definitely helps as a go-to person in case there's something that wasn't understood about the system. Why is my numbers coming up like this? I don't understand this. There will be a lot of, especially for new implementations, there will be always new users who are learning, etc. So having somebody in your organization who can answer those kind of questions and who can be the go-to person, and definitely helps make the post-implementation world a much calmer place. And finally, do not assume that you will not have change requests. Change requests are a fact of life. Especially when you start using the system, you learn, and as a result, you have new requests. Like you can have new exception rules that you need, or you may want to improve existing processes, etc. No matter how much time you spend upfront, there will always be on the design. There will always be things that you will learn after the fact, and as you start using the system about your business and the integration of your business to the system. So do plan for some change requests even after go live, and potentially maybe after 6 months after you went live with the system. Let's have a revisit of what we did and what are some of the key learnings and how we can make it even better. So that's really all I had. I hope I didn't bore you a lot. And there was some useful information in this. But right now, I'm open to any questions that you have.
Thank you very much, Emre. I sent you the questions in the chat box. Do you see that?
Okay. Yes, I do see them.
There are several questions that have been asked throughout the webinar. If you want to address those.
Right. So the first question is, how do you set up an offshore support model considering SLAs, time zones, volumes of calls? Offshore support models, of course, have been very popular due to its typical cost savings. You typically there are third parties who provide really who are really experts in these, and if you're not trying to take this on, if you're not like an international organization who has capabilities to do this in-house, my number one recommendation would be to work with an expert that has some presence in that offshore company, offshore country, and there are lots of capabilities. But one thing, of course, I just want to call out from a try to work with people who have supported similar systems in the past. And make sure you do the due diligence in checking their references and understand that they really have the people in-house who are capable of supporting your application. But my recommendation would be to work with experts instead of trying to take this on your own. And I will just leave it at that. There's a second question. It says, how much? Oops, just scroll too much. How much can you accomplish with the vanilla rollout of Oracle RPath, and what are your thoughts on customizations to the out-of-box solutions? So Oracle RPath is the platform that RDF, Oracle's demand forecasting, is built on top of. And what RDF and RPath provides is a very flexible platform. It's kind of like a loose tool set that allows you to create a lot of different pieces of functionality that you may need, and that's easily customizable to your business. However, they are all still done in the base package of the application as a configuration. We call those configurations. So really, in RPath, since after the 9.x version, starting with the 11, there is really not a lot of flexibility in pure customizations, which means that let me define configuration and customization. Configuration is the act of using standard tools in the platform to come up with your own business process or own functionality. Customization, I would define it as making changes that goes beyond configuring the solution to the base code or the base utilities, so that you are no longer on the support path. You're not, you cannot patch your system because you're using a custom version of the tools. That's, I would not recommend customizing. I would not recommend customization, but I don't think you need customization. You need to come up with any customizations anymore, because it really, RPath in particular, provides a wide variety of solutions that can be accomplished through configuring the system. And there's a specific case out there maybe we can discuss, but definitely, it's very flexible. And as far as vanilla rollouts, on RPath platform RPath is a platform, it's a loose tool set. So like for applications like MFP or assortment planning and things like that, there is really no vanilla solution. It's always like, what do you want for your business? If you're talking about RDF, it's still you still have to go through a design to at least decide on what are your source levels, final levels, the different exception rules you want to set up. So there needs to be some type of configuration to your business no matter what. You cannot just take a solution and stick it into your organization. There are different hierarchies, data, etc. So, I think there is limited availability, but what you can do during the design of your solution and design of your configuration is to analyze cost and benefits of different pieces of functionality, and maybe you try to stick to the easiest configuration possible. And if you're concerned about the budget, you can keep the budgets low, but still have it somewhat configured to your business. Next question is, what's typical engagement size duration for large retail considering an offshore blended model? This is a difficult question because first of all, I guess the engagement needs to be defined, whether it's a forecasting implementation, forecast optimization, or something else. And the onshore-offshore blended model does not necessarily provide improvements on the duration and the size of the project. It just may have some cost savings because typically the offshore resources are cheaper, and especially for some more commodity tasks, they do a great job, and I would recommend using them where possible. So as far as the size of the engagement, it really depends on the engagement, but large retailers typically have more sophisticated processes, a more variety of merchandise. That means, some large retailers do have everything. Like they have fashion, they have grocery, they have fresh products, they have hardware, and so depending on the range in your business, it may be appropriate to define different processes for different categories in your business. Therefore, it will be almost like parallel implementations of parallel configurations of multiple things, and it can, of course, be twice or 3 times more than a smaller retailer in terms of the size of the engagement. Do you know what Oracle's market share is within retail analytics? I unfortunately do not know this information. I think there may be some white papers or maybe Gartner analysis out there that can elaborate on this, but I don't have this numbers off the top of my head. Would it be foolish to consider Oracle RPath if you are a Microsoft SQL Server shop? I don't think so. I think Microsoft SQL and Oracle RPath are totally different. They are, very different architecture, very different. I think they would serve you different different clients differently. Oracle RPass has its own kind of market, and I don't think it would be foolish to consider it because there's no overlap with your existing customer base, and if anything, it can you may improve your customer base. How would you differentiate this retail-specific product versus the Mantra ASCP? I have limited knowledge of the Mantra. I honestly have not used it or have not implemented it in my past life. But one thing I can say about Oracle side is that it really, Oracle's product in particular is very powerful in terms of configuration and in terms of flexibility. I would say that it's more like a loose tool set, where my impression of the Mantra is a little bit more structured, a little bit more predefined. So if you're somebody who would like to stick with, again, similar to the previous question, something more vanilla, maybe the Mantra may provide you some more features out of the box versus the other one. It's kind of more designed, or more you're better off kind of configuring the different options for your business. So if you want a little bit more flexibility, I think maybe RPass may be a better way versus the Mantra. But again, I put a disclaimer on this comment because I'm not, I don't consider myself as an expert on the Mantra. That's all the questions I have here.
Okay. Well, thank you all for attending, and Emre, thank you very much for speaking today. We will be following up with an email in the next 24 hours with a link to access the webinar online, and all of our previous webinars are located on our YouTube and Vimeo pages for your reference. Thanks again, and we look forward to next time.
Thank you, everybody.